Algebra 1, Lesson 11.3, Simplifying Rational Expressions. So this is 11.3, Simplifying Rational Ooh, sorry. Hand toward the top again. I've been doing better with that though. Expressions. So we have again fractions, and the denominator has a variable in it. All right? And we're going to do a little bit with simplifying these. There's a little bit from this lesson, at least as far as the textbook is concerned, that we are omitting for the sake of making things just a little bit more streamlined for wrapping up this school year. But basically, two of the topics that we are still covering. So, first, there's a little bit more with the excluded value. Okay. So, there's one topic of stating, or I'll say finding the excluded value. Finding the excluded value. And what we want to do here, well, the idea is the denominator cannot be 0. It's undefined, it is infinity, it breaks the universe, variety of ways that you could look at it. And it's just nonsense, right? Like, I know what it is to have 2/3 of a pie. I know what it is to have 2/1 of a pie. In other words, two whole pies. I might even know what it is to have, okay, so fractions like that, right? But what's 2/0 of a pie? What's 2 divided by 0? 2/0 of a pie. It's nonsensical. So here's what we do. The denominator can be 0. So how we do these is step 1. Take the denominator, and set it equal to 0. And step 2, solve for what value or values of the variable or variables would no, actually, I'll just say solve for the value or values. The value or values of the variable or variables that make the equation equal to 0. Now you did this a little bit already in lesson 2. They were just a little bit simpler denominators than what sometimes we will be dealing with. We're going to have to dust off our factoring and solving quadratic equations shoes a little bit in order to do these. So here's what these can look like. Example. So all of these are find the excluded value. Find the excluded value or values. As you know, with quadratic equations where there's an x squared, there will usually be two different solutions, two different answers. So here's our first one. Let's deal with negative x over x squared minus 49. All right. We don't care about the numerator. All we care about is the denominator. So we're just going to take this denominator and we're going to say x squared minus 49 equals 0. That's C. Take the denominator and set equal to 0. I took the denominator and I said equals 0. Now we need to solve. That was step 1. Now step 2, solve. Okay, so we have x squared minus 49 equals 0. We have something squared minus something squared. We can factor that as square root plus square root times square root minus square root. Square root of x squared is x. Square root of 49 is 7. That's why I was saying square root plus square root times square root minus square root equals 0. So now I have a factor times another factor equals 0. So I can say x plus 7 equals 0, or x minus 7 equals 0. So then here x equals negative 7. Here x equals positive 7. These are my excluded values. If I try to plug 7, well, if I try to plug negative 7 or positive 7 into the original equation, I'll get a denominator of 0, and I will break the universe. All right, let's do one more. One that does not involve the difference of squares. Here we have 12. Let's use an n, because it doesn't always have to be x. 12n over n squared minus 3n minus 10. All right, what do? We grab the denominator, and we set it equal to 0. So I'm going to say n squared minus 3n minus 10 equals 0. Now I solve. All right, so we want to factor this. I have a 1n squared, so that means I can just look for what two numbers multiply to be negative 10 and add to be negative 3. So negative 10. Let's see what that factors to be. I could do 2 times 5, but it's negative, and I want it to add to be a negative 3, so I want the larger number to be negative. So I'm going to say negative 5 times positive 2. And let's check. Negative 5 times positive 2 is negative 10. Negative 5 plus positive 2 is negative 3. Okay, cool. So because this is a 1n squared, I can immediately factor this as n minus 5 times n plus 2. That's that negative 5 and positive 2. Negative 5 and positive 2 equals 0. So I've factored it. Now I can take each factor and set it equal to 0. N minus 5 equals 0, or n plus 2 equals 0. So then here n equals 5, and then here n equals negative 2. So these, again, are the two values that I am not allowed to plug into my equation because it'll give me a denominator of 0. Okay, so that is that kind of problem. And then the other kind of problem that you have in this lesson is simplifying. Simplifying. Let's see. I'm just realizing there's a lesson where we did some stuff, and I'm trying to think of what lesson that was. I was dealing with stuff with exponents. No, was that chapter 8? Maybe. No, chapter 8 is factoring quadratic. Chapter 7, polynomials. Ah, chapter 7, I bet. Yeah, here we go. Sorry, not multiplying. Well, kind of. Dividing, maybe. 7, 8, no. Oh, multiplying polynomials, that's not what I want either. Adding and subtracting. Lesson 4. Nope. I think I'm close. Lesson 2, 7.2. Yeah, there we go. Okay, good. So, here's what I would check first. If numerator and denominator are both monomials, It's a lesson. I'll say lesson just so it's clear. Lesson 7.2 problem. So let's see what that looks like. Let's do an example like that. So that would be like simplify, and let's simplify this 32 x squared y divided by 2 x to the fourth y. And let's add a couple z's on there too. Z cubed there and a z there. Okay, so you've seen this before. You can just take it type of thing by type of thing. I would take the numbers first, and I would look at what I get. So the numbers, 32 over 2, that simplifies to 16 over 1. The x's, my approach here was what I recommend is to say, is the power of x bigger on the top or on the bottom? It's bigger on the bottom. By how much? By 2. So I put an x to the second power on the bottom. Next, I look at the y's. Is it bigger on top or bottom? Neither. It's a tie. Ties get eliminated. Then I look at my z's. Is the z bigger on top or bottom? Bigger on top. By how many? By 2. So I put a z squared on top. And so then I would simplify this to be 16z squared over x squared. I don't need the 1 because that's an understood 1 in front of the x squared. Okay, hopefully that rings a bell. Let's do one more. That, yeah, same kind of problem. Slightly different flavor. So simplify. This time, we're going to have to do a little bit of work first to multiply before we divide. So we have a 4t cubed, 4t cubed times a 2t divided by 20t. You know, I'm going to change, sorry about this, I'm going to change that cubed to a fourth. There we go. Divided by 20t squared. There we go. So simplify 4t to the fourth times 2t, all of that over 20t squared. Now you can do some simplifying before you don't have to multiply this top out, but oftentimes I think it's going to be better just to start out by multiplying it all together. So 4t to the fourth times 2t's, that gives us 8t to the fifth over 20t squared. Okay, and now we can look at the numbers. 8/20ths, what does that reduce to? Well, let's see. 8 doesn't evenly go into 20. So I would say they both divide by 2. Yes, that would become 4/10ths. And both of those are divisible by 2. So that would become 2/5. 2/5. And then how about the t's? Is the power of t bigger on top or bottom? On top. By how many? By 3. So that gives me a t cubed on top. I said cubed, I wrote squared. Let's actually write what I say, t cubed. Now you can leave it like this, just 2t cubed over 5, or that's the same thing as 2/5 t cubed. Either way is okay. Most would argue that the second one is a little bit nicer, rather than it just viewing the 2/5 just as a number that is getting multiplied by t cubed instead of a 2t cubed all divided by 5. I prefer the second way. Okay, so that is that flavor of problem. And then the other flavor of simplifying is like this. So I'm going to give a new step 1. If the numerator or denominator has multiple terms factor. Then look for common factors on top and bottom that can cancel each other. And then step 3, do any further possible simplifying. Okay, let's do something like this. So like two more sample problems, and that'll do it. Example, simplify. This time we're going to do a squared plus 3a. Now let's do with x. X squared plus 3x divided by x squared minus 3x minus 18. X squared minus 3x minus 18. All right, so this is not like our previous examples, because our previous examples, it was all one chunk. One term, one term. One term. I mean, technically two, but they're being multiplied, so it's all just multiplication. Here we have some addition and subtraction that is separating stuff. So we have multiple terms on the top, we have multiple terms on the bottom, okay? So we have numerator, in this case, a numerator and a denominator that have multiple terms. So we need to see what we can do to factor each of these. So let's see what I can factor here. Top, I have two chunks, and the first thing that I check when I have two terms is to see is there a greatest common factor that I can pull out. And they both have x in common, so I can factor out an x. So that leaves me with the x squared divided by this x leaves me with x. And my plus 3x divided by this x leaves me with plus 3. Now I can always check to see if I did it correctly by re-multiplying this and seeing if it takes it back to what I started with. X times x is x squared. X times 3, we get this or plus. X times 3 gives us that plus 3x. Cool. Now on the bottom we have three terms. There's no greatest common factor. So I'm going to, and it's a 1x squared. So I'm going to look for two numbers that multiply to be negative 18 and add to be negative 3. Let's see. Well, 18 is 6, 12, 18, 6 times 3. And I want the bigger number to be negative to give me so that when they add, I get a negative. So negative 6 times positive 3, right? Negative 6 times positive 3 is negative 18. Negative 6 plus 3 is negative 3. So my bottom can factor straight to an x minus 6 times an x plus 3. Now at this point, I'm giddy with excitement because I see, ooh, I have an x plus 3 on the top and an x plus 3 on the bottom. That cancels that. And I'm left with x over x minus 6. And that is as far as that can go. Now, sometimes these will also have the instructions and state the excluded value or values, which is based on not my final answer, but what I originally started with, because I have to pay attention to what I originally started with, what I'm not allowed to plug in. So if I do this part in yellow, okay, then I need to say that the denominator, x squared minus 3x minus 18 equals 0. That will give me the values that I'm not allowed to plug in, which I already factored the bottom. So this, I've done most of the work already. This factors to x minus 6 times x plus 3 equals 0. So then x cannot, so, well, x minus 6 equals 0. I'm going to jump straight to x equals 6 or x equals negative 3. So those are my excluded values. So this whole thing simplifies to this, but I'm still not allowed to plug in a negative 3. Even though a negative 3 works for this, it breaks the universe here. And one more example. Same kind of a deal. Simplify. We'll just do the simplification, even though the homework will probably say and state the excluded values. Simplify. Let's do 2y squared minus 14y over y squared minus 49. Okay, we have multiple terms, so let's see what we got. The top, it's two terms, so I check first to see, I mean, always check first to see if there's a greatest common factor, but especially with two terms because with with two terms, there's only one instance in which we know another way to factor. With three terms, that we have multiple tools. So with two terms, let's see, what's the biggest thing I can pull out here? I can pull out a 2y. So I have a 2y times 2y squared divided by 2y leaves me just with a y. And then minus 14y over 2y leaves me with minus 7. And then divided by, so my bottom, I don't have a greatest common factor, but I do have something squared minus something squared. So this factors to y plus 7 times y minus 7. And I like that I have a y plus 7 on top, y minus 7 on top, and a y minus 7 on the bottom. Those cancel. And I'm left with 2y on top, and what am I left with on the bottom? Y plus 7. And my excluded values, I can tell from the factoring here, excluded values would be y is here it can't be a negative 7 because if y is negative 7, that'll make that chunk 0. And here if y is positive 7, it will make that chunk 0. So I'm just going to say plus or minus 7. And there we go. That is that lesson. Hopefully that makes sense, but if it doesn't, give me a holler and I'll help you as much as we are able to connect and for you to, what am I trying to say? As much as you have availability and I am willing to help. All right, there we go.